Welcome back, Physical Science 20. This is part 2 of the video dealing with percentage yield. So chemists often report the percentage yield when they synthesize a new compound or develop a new way of making an existing compound. This information gives other chemists an idea of how much product to expect if they repeat the procedure. In a typical percentage yield problem, you're given the masses of the reactant and the mass of the desired product. Here are some helpful hints. So use stoichiometry to determine the theoretical yield. So ideally, it could be a limiting reagent question, which you have to figure out what is limiting first. Then once you have the limiting reagent, figure out what you should get for product. And then if you're told which of the reactants is the limiting reagent, okay, so, and for most part, I'm going to be starting you off there, assuming that we know what is the reactant that actually gets used up. So we have that. You can figure out the theoretical yield. Then we could look at, make sure that the actual yield and theoretical yield are expressed in the same units. For example, both grams or both moles. Note that the percentage yield has no units because it's a comparison of what you actually get with what you should have got in terms of the theoretical yield. All right, so what we'll do is we'll go through an example here. Methanol, CH3OH, can be made by the synthesis using carbon dioxide and hydrogen, as you can see in the equation below. During an investigation, 20 Gs of hydrogen was reacted with excess carbon dioxide to produce methanol. So that tells you that, hey, I have 20 Gs of this, and I have excess, which means I have as much of this as I need to ensure that all of this gets used up. So that is going to be the limiting reagent. So when you're told that you're given something and you have excess or extra of the other item, that means you have more than enough to make sure that's used up. So calculate the theoretical yield of methanol. So we're going to figure out how much of this should we get. So of course, just like before, we're going to have to figure out how many moles this is, and then go from moles to moles, then figure out how many grams I should get. Okay, so that's going to be the theoretical yield, and then calculate the percentage yield if this is what I actually get in the experiment. So there's the actual. Okay, so we have to figure out the theoretical yield, and then from there move on and figure out what the percentage yield is going to be. All right, so in order to do that, you can see we have a grams to mole, moles to grams relationship here, so we're going to have to figure out the molar mass of both of those. So molar mass of H2 and the molar mass of CH3OH. So here we have two hydrogens. I'll just move my camera over just a little bit. There we go. So you have two hydrogens. 2 times 1.01 equals 2.02 grams per mole. Okay. Methanol, I have 1 carbon. 3 plus 1 is 4 H's. And 1 oxygen. It's going to give me 1 times 12.01, 4 times 1.01, 1 times 16. So that's going to give me 12.01 plus 4.04 plus 16. So that works out to be 32.05 grams per mole. So going over here, I can figure that all out. If you'll notice on the next page, you'll see there's more room there. So I think I could start it over here, but I think what I'll do is I'll move on to the next page because there's a little bit more room over there. Yeah, so if you look over here, it says solution. There's more room. We'll look at over there. So starting off with what I got. So if I look here, I have 20 Gs. So 20 grams of, what is it here? Hydrogen. And of course, the first step here is to go from grams to moles. So of course, that's going to be using the molar mass of hydrogen here. 2.02 grams of hydrogen is 1 mole of hydrogen. So as per usual, so we have moles of hydrogen. Now to go to moles of methanol, 3 to 1 moles. 3 moles of hydrogen is 1 mole of methanol. So if I was to stop the question right there, I would be here. Now, of course, I have to figure out how many grams that is by using the molar mass. So for every 1 mole of methanol I have, that is equivalent to 32.05 grams of methanol. All right, so if you calculate that all out, we get 105.7755 grams. If I round that off to, let's see here, 3 sig figs or 4 sig figs. I'm going to put it to 4 sig figs because our actual yield is in 4 sig figs. So that's going to give us 105.8 grams of methanol. So that is my theoretical yield. Okay, and part B, if I actually get 102, what's my percent yield? So, of course, if you look here, theoretically, I should get 105.8. Would I actually get 102? So notice that is less, which it should be. You actually get more than less than what you calculated due to the loss of competing reactions or spillage, etc. So when you're doing part B here, figuring out percent yield. Of course, as we looked on the previous page there, it's actual yield over theoretical yield times 100. So what we actually got was 102.0 Gs. What we theoretically should have got was 105.8 Gs times 100. So you can see grams and grams cancel. And then we'll see what we actually should get. In this case here, when you calculate that 102 divided by 105.5, 96.4%, which is not bad. We're getting a fair amount of it in that reaction. All right. So that's one example. So maybe pause the video and see if you can try the next example here. This one here. So see if you can run through that process and then press play, go through the video, and see what you get. Okay, if you had a chance to look at that, hopefully you did, try it out. A very similar question. Impure nickel can be purified by first reacting it with carbon monoxide. Okay, calculate the theoretical yield of nickel carbonyl in this reaction if 23.5 grams of nickel reacts with extra, as much as we need carbon monoxide to make sure that all of this nickel is going to be reacted. Then calculate the percentage yield if this much is collected. So that, of course, is the experiment. The experimental amount is always the actual amount. And then over here, of course, that is the theoretical, what we should get versus what we actually get. So, of course, here, grams to moles, moles to grams, we're going to have to figure out the molar mass of nickel and the molar mass of nickel carbonyl. So nickel here, we just have one nickel. So that's 1 times 58.69, so 58.69 grams per mole. Over here we have 1 nickel, 4 carbons, 4 oxygens. And then we have that, and we have that. So 58.69 plus 48.04 plus 64. So that's 170.73 grams per mole. All right, so now we're ready to do the question now. So first part here, change nickels into moles. So we have 23.5 grams of nickel. And according to this, for every 1 mole of nickel, we have 58.69 grams of nickel. Okay, so we're right here at this step. So then 1 makes 1. Okay, that's pretty easy. So for every 1 mole of nickel I have in the equation, I get 1 mole of nickel carbonyl. I guess maybe I should show you what I'm doing here. There we go, sorry. So 23.5 grams to 1 mole. So we have the molar mass, and then the balanced equation, 1 mole to 1 mole. All right, so 1 mole to 1 mole, and then lastly going from moles to gram using the molar mass of nickel carbonyl. For every 1 mole of nickel carbonyl, that's 170.73 Gs. All right, so you plug that in your calculator. I think we get 68.3618 grams, which, let's see here, round it off to 3 cigs, because here our actual is 61.0, so 68.4 grams of nickel. Hey, and that makes sense. We should get more, theoretically, but of course, actually, it's always less. So the experimental amount is always less than what you should get. So percent yield is actual over theoretical times 100. So in our case, what we actually get, 61.0 Gs. What we should have got, theoretically, we should have got 68.4. So grams and grams cancel, 89.2%. So you can think of it as, really when you write a test in a class, that's a percent yield as well. Theoretically, you should get 100%, but of course what you actually get is so many marks out of whatever the test is out of. So you can think of it in a similar way. Okay, so that's it, folks. I'll have so you can try the assignment that goes along with this, and you should be able to work through that. All right, we'll see you again.